Okay, first hour, here we go. On these logarithms today for this assignment, you got two things you got to pull off. We got to be able to expand them out, and we got to be able to condense and combine them together. So expand them, combine them. This is what we're doing. So here's your rules. First rule, when you have two things multiplied together, when you have a logarithm where m and n are multiplied, you can expand these by addition. One logarithm plus the other logarithm. So when it's multiplied, you expand them by addition. Second example, when they are divided, you can expand them by subtraction. So your logarithm that's on top is first, subtract the logarithm that is on bottom. So real quick, multiplied, expand by adding. Division, expand by subtracting. We have another cool rule that's going to help us today too with exponents. Let me show you this one real quick. Whenever you've got a logarithm and you have an exponent up here, there's a cool move with logarithms where you can grab this exponent and you're allowed to move him and put him out in front. So he was an exponent, you're allowed to move him out in front as a coefficient. So those are three pretty good rules that's going to get you through the assignment today right now. All right, let's expand them, let's combine them. Here we go. Let's start with expand. All right, here we go, log. Let's just say we got anything down here, base 8, and here's 12. Let's go with an exponent. Now let's just do a variable x. So here's a problem you'll get on the assignment. Say, expand this. So you check your 12 and your x multiplied together. Since they're multiplied, we expand this by addition. So here's your logarithm for 12, here's your logarithm for x, multiplied here, expand it, addition there. That's how that works. Let's do another one. Let's say we've got another logarithm, and let's say there's no logarithm, no base given to you. Okay, kind of an understood 10. Let's put in a 10. How about 10y to the 6th? So here's what will happen to you a little bit. They don't give you a base for your logarithm. So anytime you don't have a base, it's like an understood 1, it's an understood 10. So if we don't have anything there, we just put in a 10. All right, let's expand it out. 10y to 6 definitely multiplied together. So when we expand this, it will be by addition. All right, we've already done enough logarithms to kind of realize like, hey, wait a minute. I know what happens here. That's a 10, that's a 10. Whenever these show up, you're like, oh, I know what happens. This just becomes a 1. You're like, I'm pretty good. All right. Whoops, I didn't draw that really well. Log 10y to the 6. Sorry about that. So you've got base 10. You now have an exponent, the 6, that's on top. We can move it out in front. And then that has got it cleaned up. So rule for us, an exponent right here, we can move it out in front. Other rule for us, the 10, 10 being the same, cancels out, makes it a 1. So that's a pretty tricky one on expanding. Let's get all this out of the way. All right, let's do a division one. 1, 2, 3, 4, 5, 6. Say we have log x to the 7th 5y squared. X to the 7th 5y squared. And again, there's no base given to you. So if no base given to us, we know it's going to end up being a 10. All right, we have a division right here. We got more stuff on the bottom. Watch how this works. So you got an x, you got a 5, and you got a y. So x to the 7th 5y squared. You have 3 pieces to this problem. So when you expand this out, you're going to have 3 logarithms. So it'll look like this. Log x to the 7th. On top, it's positive. Division means we subtract this. So we've got log 5 log y squared. So the 5 and the y were multiplied together, so we're going to hit it by addition. But we know what happens when there's a negative sign out in front. This negative is going to hit both of those. And so our signs are going to change. Kind of an easy way to remember this. This is the way I always remember it. If it's on top, it's positive. Period. Doesn't change. On top, positive. If it's on bottom, the 5 and the y squared ends up negative, negative. So anything on top turns out to be a positive. Anything on the bottom turns out to be negatives. That's a great, easy way to remember that. All right, let's fix these exponents out in front. Exponent out in front, and then we're done. Log 10, 7, oh, log 10x, sorry. Minus log 10, 5, minus 2, log 10, y. So there you go. That be a final answer. All right, expanding them. Let's do another one with the square root in there. Do I got one of those? I do. So here's 7. Okay, so we walk up to this one. We see the 9 and the square root of x are multiplied together. Since they're multiplied together, we're going to expand by adding. You have a 9 and you have a square root of x. So you have two things, the 9 and the square root of x. Two things means you're going to get two logarithms. So multiplied together means expanding by addition. Now you can do something with this square root. Nothing else to do here, but watch this. Instead of writing square root of x, square root can be represented by half power. So what's square root? Square root's half power. And now it's an exponent, half power, that you can move out in front. So looky there. Change the square root into an exponent. Half power as an exponent you can move out front, and now you got your final answer. All right, so we just did a whole bunch of expanding. Let's go the opposite direction, and we'll combine them, we'll condense them back down into one. Let's do this. So, number 8, so we had logarithm, what do we got here? 320. So we have these two logarithms, here and here. They're hooked up by subtraction. We're going to do the process in reverse. So they're already expanded out. We've got to condense and combine them together. So if it's subtraction, when we combine it down into one logarithm, we use division. So if they're subtracted here, it's divided there. Oh, and we know 20 divided by 5. That's 4. And you just got your final answer. Yeah, you did. All right, let's do another one. All right, what do we got here? 8 log 6 to the y. Yeah, you'll like this. There's not a whole lot to do here. Before we can really start this problem, we do the opposite, the reverse. So if it's out in front, the reverse process, we can take it and move it back into an exponent. So when we expanded it, we moved it from here out front. When we combine them together, it's the reverse. We move from out front to an exponent. This is addition. So we're going to put it together as one logarithm, but we've got to multiply the y to the 8 times the 5. And really you always write the number first and then the letter, so it looked like that. All right, let's do one last one on combining, condensing logarithms all the way down. Let's do a giant one here. 3 of them, so we'll take 3 logarithms. Let's go 3 logarithms all the way down. Okay, so here we go. We've got 1, 2, 3 logarithms. We're going to condense it all the way down into just 1. That's our job. Condense them down, combine them all together. We start off, let's do this. Take everything that's out front, move it up. Out front, move it up. Out front, move it up. So we're doing it in reverse. So if it was a coefficient out front, it moves up to an exponent. So we make that move happen. All right, now we start looking at combining it all down into one logarithm, all the way down to just 1. All right, I've got 4 right here as my base. I've got positives that are always on top, positives that are always on top. This is a negative, which means he's going to be on bottom. So positive, push it up, negative, put it down. So x to the 9 selling negative, we know he's going to the bottom. All right, oh, hold on just a sec. Oh yeah, we'll do it here just. So you've got 2 to the 3rd up top, you have y to the 13th up top. So positive up top, negative on bottom, positive up top. Real quick, we can fix that. We know what 2 to the 3rd is. It's an 8. So this will become log 4, 8, y to the 13th, x to the 9th. So that's the process for this assignment. You got to expand them out or start with a bunch of them and combine them all the way down. A whole bunch of logarithms just for you guys.